Nowinski, General Manager for Avantes North America. I'd like to tell you a little bit about a fiber optic spectroscopy system that we have before us today. It's a very special configuration. It's a fiber optic dissolution monitoring system for a process monitoring application. This type of application would be particularly applicable to industries like the chemical industry, the pharmaceutical industry, where we're looking to monitor a reaction in process or a dissolution in process, and we want to do that over a variety of different sampling points. So in this system, we've actually got four sampling points set up. This is channel 1, which is a flow cell, channel 2 and 3, also flow cells, and then we have a transflectance dip probe in channel 4. The system consists of a spectrometer and a light source, which are in an integrated module. Optionally, we can configure with more than one spectrometer, but the beauty of this other module, which is our FOM 2x8, which is the fiber optic multiplexer with a 2x8 configuration, allows us to use that one channel and to collect data from 8 different sampling points, not in a simultaneous fashion, but in a serial fashion. The sampling, however, can be quite fast. To give you an idea, in less than 60 milliseconds, we can move from one position to the next. So we can literally sample in under a second over all 4 of these channels very easily. Now, the system in this case is set up with a spectrometer that covers the range from 200 to 1100 nanometers. We can also extend that out into the near infrared, out to 2.5 microns. We use light sources of a variety of types depending upon the needs. For UV, we use deuterium halogen or deuterium only. For the visible, obviously halogen and deuterium. And for the near infrared, halogen again. But any of these types of light sources are available in this platform and can be integrated into this module. The fiber optic multiplexer, the way this works effectively is that one channel at a time, the fiber optic multiplexer is directing light into a single channel, and that light is then being measured via the multiplexer by the spectrometer. And the software controls this and tells the software then reads the signal and knows that that particular channel is associated with that data point, and the data can be saved. And then it moves on to the second channel, the third channel, and the fourth channel. In between each channel, we can also do a reference, which is very important correcting for light source drift. On our software, which is called Avasoft, this is our proprietary software. Many of our customers choose to use our own software. Some choose to write their own software. Either is possible with the Avantes platform. In this case, we have a tiled function within Avasoft, which is a very nice feature. In this case, we have scope mode, which is basically we're looking at raw A to D counts in this pane. Then we have 1, 2, 3, 4 more channels where we're measuring each of the individual channels, and it's sampling at a specific wavelength. The beauty of Avasoft is we can set up multiple of these time series collections, and we can be monitoring data over a single wavelength or multiple wavelengths. We can also take a wavelength range and monitor the integral under the curve of a wavelength range. So there's a great many options, and the configuration of the multiplexer is totally programmable within Avasoft. For more information about your applications, if you'd like to talk to us about a dissolution or reaction monitoring application, please contact a sales engineer at infousa@avantes.com. Thank you.